So these are already known values. Now when we find the difference between the value which we know, which is C, and the value which we guess, for example, C dash. So here I'm calling it C dash because we already know the actual value of C and the value which we guessed is C dash. Then we come to a difference. So for example, that can be the delta, some people say, or in actual term, that is the error. Now there is an error, and that error we are getting because there's some of the known value within our data which we compared with. Now based out of this error, we then refine our assumptions, which are alpha and beta, because C is the constant here. So we refine alpha and beta. We say, okay, let's go and add 0.0002 to alpha, and let's add 0.000001 to beta. So a small increment, and we do that with alpha and beta. Now once we do the increment, we are basically refining the guess, and once we refine the guess, then we compute again the new values like we did here with this equation. So this is the equation here, and we basically again compute the new values for all of the products probability, and we again find the error, and based out the error we again refine the alpha and beta, and this process goes on for a long time. Now what will happen at certain point of time, these are some equation which we use in linear regression, and the new value, basically the new a dash or b dash, will be based out of the old value plus alpha plus a plus beta. So these are examples of how the new values are actually calculated. Now we were discussing that at some point of time we will reach a point where the alpha and beta, the learning parameters, would be giving out the values of a double dash, b double dash. I'm saying b double dash, but there might be a lot of iteration which happens to really come and guess this value, c double dash. Now this set of alpha and beta, when we use, we are able to minimize the error to its minimum. So our objective in the machine learning is always to minimize the error between our guess and the real value. And when we come to the point where we have minimized the error to its minimal value, then we basically take that alpha and beta value and we say we got it. Now whenever we are using this alpha and beta value and guess, we would be getting somewhat right result or output of an unknown variable or situation, or maybe can be a parameter. So this alpha and beta value with a minimum error is what a machine learning algorithm stores and uses over the time. Now how this alpha and beta are then further refined, or this entire process of refinement is also technically known as tuning, and this alpha and beta are the learning parameters. So together it is called parameter tuning or learning parameter tuning, and we will be discussing the math side of how we basically from a maths background can assure that we are going the right direction and actually it works. So we will prove that with math as well, and this is the entire step of a machine learning algorithm implementation. They first understand what is known, they guess what is unknown, and they find the error of how much we are deviating from the known, and they try to minimize the error by tuning the learning parameters. Now let's go in the next step and try to dig deeper of how the guessing happens and how the error is minimized. Now one question which comes most of the time in this particular explanation of machine learning is, how do we know that when we initially guess and tune our parameter, we are moving towards right direction. We can go in a completely wrong direction also. And how do you know that by only tuning alpha and beta, we will be getting the right result? Now, to know about the answer, we will go in the next section and check out the math side of the machine learning model. In this case, this is matrix factorization, but it will be applicable. The model or the way of thinking is applicable to all the machine learning world itself. And if you know one algorithm properly, then you will be also able to correlate similar algorithms. So let's go ahead and see the math side of the equation.